Hello, I would like to make a video to talk about science and astronomy, and I've been rewatching the show Stargate SG-1, one of my favorite shows of all time, and it just gave me more information on astronomy and science, and that was the topic that I was interested in when I was younger, and so I thought good time to recap and see the uh, refresh my mind on the topic. So, I remember taking a lot of courses on this topic when I was after high school, and even in high school, we had science, physical science, so the elements, we learn about the elements and the atoms, and my brother was very interested in constellations, and he was making a map out of the sky with the constellations. And my grandfather had a telescope, and I think he was the one that made us interested in this topic. To compete with my brother, I also learned more about space and astronomy, and learned everything that I could about the topic. And it's still a topic that is interesting to me now because there's constantly new discoveries, and we have a better picture of what is reality of out there outside of our solar system. So, well, one of the big changes that we know now is that there are more planets than we thought, because there's exoplanets all over the place. Where when in the 90s we didn't have any confirmations of planets that were outside of our solar system. So I just thought that's nice to know. Is it making me money? Is it useful? Or it just gives me a good picture of how we understand the universe. And as a JW, uh, we think that the universe is a creation, and it was created 5,000 years ago, in the 5,000 BC, so 7,000 years ago. And that it was that what the scientists are saying about the Big Bang, that doesn't exist, that never happened. There's no such thing. And so to be reading on and knowing more about this, I thought they're wrong. If they're wrong, we know we have the truth. So they're wrong, and I will. If we have the truth, then let's just listen to what they're saying. And then I realized that this just can't be true. They have something wrong with their theories because they think that there's a red shift, the Doppler shift, which is the fact that the galaxies are going farther and farther. We are seeing a shift in the electromagnetic spectrum, where the visible light is shifting towards the red, which is shows that the light waves, the electromagnetic waves that we are receiving, are being stretched. They're being there's a slowing down. So we're trying to understand why the further the galaxies, the bigger the shift, and eventually at the point where it's no longer visible light, it becomes microwave light. So to me, it just makes no sense that there's a expanding universe because it's just not compatible with the creation. So I try really hard to disprove this and try to figure it out, like an explanation. And the more I was researching it, the more I found that to be true. That it is expanding. The universe is expanding. There's no other explanation. That's how it is. So means that the Big Bang is a good explanation, and the creation is not. So it doesn't say that the creation never happened. It just says that the universe is not static. It's not the. It is dynamic and it is expanding. And just to understand the gravity, to understand what the big aha moments in science and astronomy that were. And I read magazines on that because I want to be up to date. And back in the early 2000s, the big thing was dark matter, and we are gonna see a new understanding with that. But now it's much more exoplanets because we know that other planets are just like our own. They have a lot of characteristics that are similar, and we can do a lot of studies in exoplanets. There's a lot of mysteries that we can uh, discover with the planets. And first of all, what's happening there, and is there life on other planets? There's no reason why wouldn't be. Uh, and So just having a idea about the dimensions of outer space and how things are connected or how they work is just useful. I think I admire somebody that has that understanding and that they don't have emotions related to it. Like they're not in reaction about it. This is something that is something to be cautious about or whatever. So I was learning about, for example, what is happening in the sun, what explains the sun that is like that, and it's actually nuclear reactions that are happening, and that's fusion of hydrogen atoms under the force of gravity that is creating the nuclear energy that is coming from the sun. So this is the recipe, I guess, for a nuclear bomb, a nuclear weapon. That you have a hydrogen bomb, and you have a which is fusion, nuclear fusion, and the bomb that is nuclear fission. Fission would be having an unstable element. And I remember that I was talking about this to some Jehovah's Witnesses, and they were on the TV and they were watching these nuclear bomb testing that were filmed in the kitchen, and I thought, okay, that's interesting. So because this is a very very big explosion that can destroy life on Earth. Uh, so uh, so the science behind it is fission or fusion, and hydrogen atoms that are fusing into helium. This is what's happening inside the sun. We can replicate that on Earth and have the when mass. This is E equal mc squared. When mass is uh, transformed into energy. It is the mass is the speed of light, which is 384 kilometers per second, times squared. That gives you the amount of energy that is released when a mass is transformed into energy. So, because what is happening is that helium is fusing the nucleus of the hydrogen is fusing into helium, and the electrons that are released, some of the electrons are lost in the process and they become energy. So this is the most biggest explosion that you can have. For the fission, that is uranium, that is an unstable element, also radioactive element that if you get to bombard it, it can split. And also there you can have a very high amount of energy that is transformed that from the mass into energy. This is from the Einstein's equation. So this is the science behind the nuclear weapons. But science is not about making war or nuclear weapons. It's more about understanding the laws of the universe and understanding, for example, the what is why is orbit, why are planets in orbit, and what's the, what are the laws that explain what we see, what we can observe with telescopes uh, and maybe on Earth as well as laws of motion, for example. So you have a Newton that had the laws of motion, which is showing that you need a certain energy that is pushed on something to make it move. However, all motion is relative. So you have a frame of reference, different frames of reference, and yet you have the same laws. And one of those laws is that the speed of light is 385 kilometers per second. So that is the same with all frame of references. So you have somebody is on a train and they are looking in a mirror. They see the light that is reflecting, but it's as the same light as somebody that would be an observer that is not in a moving thing, and the light is the same. But to the observer, the light would have had different distance that it and also different time. So it's the space and time is relative because the speed of light is constant in any frame of reference. So that makes it possible that if something is going close to the speed of light, time is slows down compared to not the speed of light. And the way that we count time is just the revolutions around our sun and the rotations of our planet, the rotation of our planet, which is the days and nights, and how we split that because it's a constant thing. And the seasons is about like I'm jumping from topic to topic, but the seasons is because of the axis of the Earth, because there's a tilt of the Earth that is 20 something degrees, and that means that on one side of the sun you get the same side of the planet gets much more sunlight than when you're on the other side, which is a different tilt, so you get a lot less sunlight. So anyway, I was interested in those things because it's complicated things, and I have good three-dimensional imagination, and I can understand it. So I thought I can understand complicated things, and you can, if you tell me that this is too complex and I wouldn't understand it, I would insist that you try to explain it because uh, I can understand very complex things. So if you can't explain it, maybe it's because you don't understand it yourself. So these are interesting concepts to be thinking about, like what is the structure of the universe? Did it have a beginning? What is the time? Its time has always been, or is it something that had a beginning? What I'm looking at is well, one thing is interesting is to know the dimensions of the universe, that you need to be able to see that, okay, the moon is this distance, the sun is this distance, the planets are this distance. So to have this is Alpha Centauri, the closest sun is the closest star is this distance, and where the planet, the closest planet, Andromeda, is this distance. And we're talking about very big distance. We're talking about light years. That means it's the amount of time that light takes to travel within a year, a Earth year. So that's 384,000 kilometers per second. And at that speed, it would take 2 million years to reach Andromeda, which is the closest galaxy. So, so yeah, it's important to have a good understanding, just the basics of uh, those things, I think. And to be able to have questions about things that you can think about, that maybe you can actually figure out things that new understandings that maybe are a little bit different from what is established. So there, I think I'm gonna leave it at that. I'm gonna finish that. I'm reading A Brief History of Time by Stephen Hawking. So that's where all this information is. There's many different sources that have this information, but I think it's pretty good so far what I'm reading. So there, I'm gonna leave it at that. Thank you. Bye.